Now, there's two ways of collecting data. Okay, in general, there's two main ways. There's lots of different ways of collecting data, but if you were to divide two overall ways of collecting data, I would divide it in the following. Okay, you could do a census. Or you could take a sample. You could do sampling. Okay? So let's look at census here. What is a census? Census is where you obtain information from an entire population. So the census is obtaining information from the entire population. Okay? So remember, population isn't just the number of people that live in a town. Okay? But it could be, like, for example, the population of the United States. And in fact, we do take a census. Every 10 years, we actually gather information from everybody in the United States, and that's called a census. It's a big process, okay? Almost a big ordeal, I should say, okay? But a census doesn't have to deal with just people. And we think of a census as something that a nation does. They take a census of their people. But, it could be like a company is interested in the weight of the products they produce. Then a census would be the weight of all products produced by a company. Okay? And a census means you would have to weigh every product that you make and keep a record of all the weights. Okay? It's a census because you're doing it for all the products. Okay? You might do ACT scores for all U.S. high school seniors. Okay, that would be a big process to gather all those ACT scores. Okay, but if you do it for all U.S. high school seniors, then you've done a census for the ACT scores. Okay? So what are some problems with a census? A census is nice because you get all of the data. You get the full picture. Okay? You know what all the data is telling us, all of the data tells you when you take a census. But there's some problems here. Okay? A census is time consuming. So when we do the U.S. Census, it takes like a whole year to do it. Okay? It's expensive. There's a lot of resources that go into that. So the U.S. Census, they have to pay people. I don't know, they probably take $1 million. They probably spend $1 million just taking a census. They probably spend more than that. They probably spend lots of money, okay, when they take a census, okay. There's also lots of room for error. If you're gathering that many values, okay, it's easy to write down some of the values wrong, even if you don't mean to, or losing some of the data, or missing some people and not even getting data from some of the people. So even when you take a census, even when you collect it from everybody, you might not get an accurate picture of all of the data. Okay? So these are all reasons that census is, I'm not sure what plural, these are all reasons a census is not always the easiest or the best way of collecting data. Okay, but let me give you one other example that opens your eyes. Okay, sometimes it's absurd to take a census, and let me give you an example. Okay, so this is a quality control task. Okay, And we're going to look at this quality control task. Let me put it up here. Quality control task. What is it? I'm a quality control inspector. I work for a lumber company. Okay? And this task says you must test the strength of boards. To do this, you apply weight to a board until the board breaks. The amount of weight the board is able to hold before it breaks is the strength of the board. Okay, that makes sense, right? So I just take each board, I apply weight to it, I keep adding to the weight, and then at some point the board breaks, and the amount of weight that it held before it broke, that's a measure of how strong the board is. Okay? Now, do you see a problem with this? What's the problem with taking a census on all the boards that the company makes? Can you see? If we took a census, then we would have to break every board the company makes. Okay? And that's absurd. Okay? So oftentimes when you test a product or when you make an observation, you actually destroy what it is that you're testing. So like finding the lifetime of a battery. If I tested every battery the company produced, then I would run all the batteries dead, and it would be absurd. It wouldn't make any sense to do that. Okay? In those situations, sampling is actually your only way of collecting data. It's the only way that really makes sense. Okay? So sometimes it's not even possible to take a census, or it's just absurd to do it. So what is sampling here? Well, a sample is a smaller group of observations randomly selected from a population used to represent the population. Okay, some key ideas here. A sample is, it's a smaller group of observations that are randomly selected from the population, and they're used to represent the population. Okay? The randomly selected, what that means, when something is random, it means that any observation in the population has the same chance of being in the sample as any other observation. Okay, so some observations are not more likely to be in the sample. In other words, when you randomly select, it means none of the observations are biased. I mean, you're not biased towards any of them. Okay? They all have the same chance, equal chance of being in your sample. Okay? And the reason for that is you want the population you want your sample to represent the population. And the best way to get a sample to be a good representation of the population is for it to be a randomly selected sample, for any observation in the sample to have the same chance of being in there as any other observation. Okay? When it's randomly selected, then it'll be a good representation of the population. So for example, if you were wanting to know the income of Iowans, if I went to a single neighborhood and collected all my observations from that neighborhood, then that would not be randomly selected. Any other neighborhood didn't even have a chance of being in the sample. Only people from that neighborhood had the opportunity to be in the sample. And in that case, that sample would not represent your population very well. It would represent the people in that neighborhood, but not the entire population. So if it was a poorer neighborhood, then your sample, the values would be lower than they should be. Or if it was a rich neighborhood, then your sample would have values that are too high. Okay? So it's important for a sample to be randomly selected so that it can represent your population. So if I were to do a picture here, let's say this is the population, and it's all the boards produced by a company. Okay? Then a sample would be 50 boards that are tested. Okay? And so they have to break those 50 boards to test them. But it's only 50 boards. Okay? So the key here is you want this sample to be a good representation of the population. So what's going on in the sample, you want it to be similar to what's going on in the population. And in order for that to happen, you want the boards to be randomly selected. Okay, so you don't want to take all the boards from a single tree or something. Okay, you want any board the company produces to be just as likely to be in the sample as any other board. Okay, and in that way, then the sample can be used to represent your population. Okay, now here's a couple other terms, a couple other things you need to know. The size of the population, we use capital N to denote that. So we're going to have formulas where we calculate values like the average or the standard deviation. And if you're dealing with a population, the formula will use capital N to denote how many observations are in the population. And if it's a sample, it's going to be little n. And this makes sense because the population is big, the sample is little. So a little n represents the size of the sample. Okay, one other term is a parameter is a number that describes a population. So if you have a number that describes a population, it's a parameter. So in this example, like the average strength of the board, an average is a number that that would describe the average strength of the boards in the population is a number that would describe that population. Okay, but a statistic is a number that describes a sample. So if it's a number that describes a sample, they call that a statistic, not to be confused with statistics, which is the science of organizing, drawing conclusions from data. Okay, a statistic is a number that describes your sample. Okay, so this would be average strength of entire population. This would be average strength of 50 boards. Okay, so any value that describes your population, like the average, has a corresponding calculation that you could do with just the values in the sample. Okay, and if it's for a population, they call it a parameter. If it's for a sample, they call it a statistic. So, you know, in day-to-day life, we sometimes think of statistics as facts and figures, numbers. Those are the statistics, the numbers. Well, a statistic is a number, but the technical definition is it's a number that describes a sample. Okay? If it were a number that described the entire population, it would be called a parameter. And then one way that you could remember this is parameter and population both start with P, and then sample and statistic both start with S. Okay? So, the reason we take a sample then is a census sometimes is very time-consuming, very expensive. It maybe isn't practical, or it could even be absurd, like this example where you actually have to break the boards. Okay, the only thing that you can do then is to take a sample and then use the information you obtain from your sample to draw your conclusion about the entire population. Okay, and when you do that, what you are then doing is inferential statistics, and this was the second type of statistics. Inferential statistics here is using information obtained from a sample to draw a conclusion, i.e., make an inference about the entire population. Okay, so that's the definition here of inferential statistics. So you're using the information in the sample to obtain, you're using the information obtained from a sample to draw a conclusion about the entire population. Okay, so instead of taking a census, you're taking just the sample. The sample is representing your population, and then you're going to draw a conclusion or make an inference. That's where the term inferential comes from. You're going to make some sort of conclusion about the entire population, but you're going to base it on just the information that you have in your sample. Okay? So if I were to draw a picture here, here's your population, and it's unknown. Okay? You could just take a census of this, and then you have all the information. But if that's not a good idea, then what you would do is you would take a sample, and a sample is known. It's a smaller group. And when you take your sample, you make sure it's randomly selected. And that way, since it's randomly selected, it'll hopefully then be a good representation of your population. Maybe not a perfect one, but then you can draw a conclusion about population. But you're basing it on the sample. Okay? This is unknown, but you're going to base it just upon what you've learned from your sample. Okay? And what we're going to learn as we go throughout this semester is that the sample isn't going to be a perfect representation of your population. Okay? But there are going to be some mathematical rules that are dictated by probability, and we'll talk more about that as we go on. But probability is kind of the mathematics of chance. So if you throw 10 marbles in a jar and 3 of them are blue, then the probability of drawing a marble would be 3 out of 10. So there's a 0.3 or a 30% chance. So 30% of the time you draw a blue marble. Okay? Well, drawing people out of a population is not unlike drawing marbles out of a bag. Okay? There's a connection there. And there's mathematical rules of probability that even though this isn't going to be a perfect picture of the population, there's going to be some mathematical rules that tell us how the two are related, so that we can make as good of predictions or we can draw as good of conclusions as possible based upon the math and not just what we think. Okay, and that's where we're headed. This whole class is going to be about inferential statistics. Okay, I should say not the whole class. The first test is about descriptive statistics. So really there's these two areas. There's descriptive and there's inferential. Okay? And descriptive is, if you've learned any statistics up to this point, it's probably descriptive statistics. You've learned how to calculate the mean, median, mode, maybe the standard deviation. You've learned how to make a histogram or a frequency distribution table or some sort of graph or chart. But those are what you've learned how to do. You're just describing the data. The inferential statistics is a deeper type of statistics based upon the mathematical laws of probability, where you're actually using information from your sample in a very precise way to draw conclusions about the population. Okay? And it's going to take a whole class for us to build up the tools that we need to do that. We're going to have to learn about descriptive statistics first, because you still have to organize the information in your sample. Okay? And that's descriptive statistics. Remember, a sample can still have thousands of values in it. Okay? And then probability, we're going to have to learn probability, and then we're going to have to learn how to make the statistical inferences. So there's kind of three things: descriptive statistics, there's probability in between as a bridge, and then there's the inferential. And this class here then will be the class here will what am I trying to say here? The class really will follow this outline. We'll learn descriptive statistics, we'll spend some time doing probability, and then we'll do inferential statistics. Okay? So those are the two main branches of statistics, and also a lot of the background about populations and samples, censuses, and things like that. Okay? So let's do a daily activity. So this is going to be your first daily activity here. And what I'm going to do here is I have an example, and I want to get all these. And the problem with this here is, in order for you to read them, I think I got to do them 3 at a time. So what I want you to do for this daily activity, I just want you to decide for each one of these, I want you to write whether you think it's descriptive statistics or inferential statistics. You can even just put a D and an I if you want to. But I want to see if you can read about the study and decide between the two. Okay? So during these daily activities, what you'll do is you'll press pause on your video player, you'll do the activity, and then when you press play again, we'll talk about the activity. Okay? And we'll go over the answers. Here we're going to have to do it in 2 steps, okay? So here's the first step. Okay, so just press pause and do this first step, and then we'll do the second step, and then we'll talk about it. Okay, so go ahead and press pause now. Okay, so if you're playing it again, then you're done with those first 3. Let me move it up, and I'll have you do the last 3. Go ahead, press pause now, and do the last 3. Okay, so you should have each one of these classified as either inferential or descriptive or inferential. Okay, this first one here about television viewing habits by this company. Okay, what they do is they take a sample of Americans and they're going to yield estimates of the average TV viewing times per week for all Americans. So all Americans are the population, and they're doing a sample of Americans to decide what the average TV viewing time. And the decision is just an estimate. They don't know the exact value, it's an estimate. So this is an example of inferential statistics. And the reason is they're using a sample here to draw a conclusion about the entire population. Okay? So this second one here, if you look at this, the Statistical Abstract of the United States has the average professional athlete salaries in baseball, basketball, and football. And they're compiled and compared for the years 1987 and 1997. This is descriptive statistics, okay? It looks like they're collecting all the salaries for all the professional athletes, and they're just comparing the 2 years. Okay, and so there's no sample being drawn and going back and drawing a conclusion about the entire population based upon that sample. Okay, so now a sample isn't enough to just because you have a sample doesn't mean that it's inferential statistics, because you can still organize the information in a sample. Okay, so you have to have a sample, and you have to draw a conclusion about the entire population based upon the sample. for it to be inferential. Okay, but that's not done here. So let's look at this one here. The U.S. Substance Abuse, let's say the U.S. National Center for Health Statistics publishes estimates of the rates for the leading causes of death in 1997 in Vital Statistics of the United States. The estimates are based on a 10% sampling of all 1997 U.S. death certificates. Okay? This is going to be inferential because they're basing the rates here, estimates of the rates, on a 10% sampling, not on the entire population. If they went ahead and did the other 90% and got all of it and looked at in that way, if they took a census of all of them, then it wouldn't have been just an estimate. It would have been the actual rate. It would have been descriptive statistics. But in this case, it's inferential. Okay, number 4, the U.S. Substance Abuse and Mental Health Services Administration collects and publishes data on drug use by type of drug and age group in the National Household Survey on Drug Abuse. The information they provide is based on information obtained from national samples. Okay, so again, since they're obtaining information from the samples and they're publishing this about the drug use, I would have said inferential statistics because it's based on national samples. If all they're doing is organizing the samples and printing the information about those samples and not drawing any conclusions about the entire population, if that's the way you thought about this and you said descriptive because you thought about it that way, that would have been okay because you can still organize information in the sample. Okay? But because it says the information they provide is based on information obtained from national samples, okay, and they're giving information for the entire population, in that sense it would be inferential. Okay, now this one, I wrote this one myself. All the other ones were ones that are actual examples, but this one I wrote just to make a point here. This one's a little tricky. Okay, it says to test products, an employee of Teletronics randomly selects 500 circuit boards and tests them. He then organizes the information he obtains from the sample and summarizes it in a report, which is presented at the end of the week to a committee of statisticians. Okay, as far as this particular person, he's only doing descriptive statistics. Okay, he's collecting information on 500 circuit boards, so he does take a sample of boards, but he tests those boards and obtains information and organizes and summarizes that information in a report. He does not draw any conclusions about the entire population. Okay? So he is only doing descriptive statistics. So now this committee of statisticians probably end up using his work, his descriptive statistics, to then do the inferential statistics and then draw a conclusion about the entire population. But as far as this guy is concerned, he's only doing descriptive statistics. This last one I would say is inferential. Okay, it's results from a monthly telephone survey yields estimates of music expenditures. So they're basing the expenditures on a survey, which is a sample, a telephone survey. They didn't survey everybody, I doubt, in the U.S. Okay, so and they're estimates. They yield estimates. So I would say that's inferential.